Today I'm going to walk you through one of the most iconic parts of classic car engineering, the Bosch contact point ignition system, like the one used in the Volvo 140 series and Amazon. I personally own 1969 Volvo 140 series, and over the years I've built a lot of experience maintaining and tuning this system. If you own one of these cars or just want to understand how classic ignition systems work, this video is for you.
Patrick's Garage.
Let's start with the role of the ignition system. In a running engine, there is only about 0.002 of a second between the spark at the plug and complete combustion. That's incredibly fast. So the ignition system's job is critical. It has to provide a strong spark at exactly the right moment every time. If the spark is too weak or happens at the wrong time, combustion isn't efficient. That means lower power, higher fuel consumption, and more emissions. The goal of ignition system is to always produce maximum pressure in the cylinder at the right time, especially at the top of the compression stroke. There are two basic types of ignition systems: contact point and electronic. While both do the same thing, creating and delivering high voltage sparks to the spark plugs, the way they do it is different. This video focuses on the contact point system, which is the older design. It was used for decades in cars like Volvo 140 series and Amazon, before electronic systems took over. The ignition system creates a spark that ignites the compressed air-fuel mixture just before the piston reaches top dead center. When the engine is idling, the spark is timed very close to top dead center, but as RPM increases, the spark needs to happen earlier to give the mixture time to burn completely before the piston comes down. There are mechanisms built into the ignition system to advance the spark timing depending on engine speed and load. So, what parts are involved? Here are the key components. The battery or alternator provides power. The ignition switch turns the system on. The ignition coil transforms low voltage into high voltage. The distributor times and distributes the spark. Inside the distributor, we have contact points and a condenser on the distributor. Then we have the spark plug wires and the spark plugs themselves. In modern electronic systems, you also have a control unit, but in the Bosch contact point system, it's all mechanical and analog, simple and effective. The system is divided into two circuits. The primary circuit includes the battery, ignition switch, the primary winding of the coil, the contact points inside the distributor and the condenser on the distributor, and the wiring. The secondary circuit includes the coil's secondary winding, distributor, rotor and cap, the spark plug wires, and of course the spark plugs. Here is what happens. With the ignition on, current flows from the battery through the coil's primary winding and through the closed contact points to the ground. A cam inside the distributor opens and closes the points at precise intervals. How long the points stay closed is called dwell. This is measured in degrees of distributor commutation. The ignition coil is a transformer. It has a primary winding and secondary winding. When the points are closed, current flows through the primary winding, building up a magnetic field. As soon as the points open, that magnetic field collapses, and that collapse induces high voltage, tens of thousands of volts in the secondary winding. This voltage is routed by the distributor to the right spark plug, where it jumps the gap and ignites the fuel mixture. Timing is everything. If the spark happens too early or too late, performance drops. The contact points act like a switch, opening and closing the primary circuit. When the points begin to open, up to 250 volts can be generated in primary circuit. This can cause a small arc across the points, which can wear them out quickly. That's where the condenser comes in. It has two main jobs. It stops current quickly, which helps collapse the magnetic field. It reduces arcing across the points, extending their life. Without the condenser, the points would burn out fast and the spark would be weak. Now that the coil has produced a high voltage surge, it travels through the rotor and the distributor cap to the correct plug wire and finally to the spark plug. There it jumps the gap, ignites the mixture, and the power stroke begins. Then the points closed again, and the whole cycle repeats for the next cylinder in the firing order. Since the distributor is driven by the camshaft, it spins at half the engine speed. So 4000 RPM engine speed, the rotor distributor rotates 2000 RPM. Let's talk more about spark advance, a key part of performance and efficiency. At idle, the spark fires near top dead center, but at higher RPMs, it needs to fire earlier. This is handled by a centrifugal advance mechanism inside the distributor. As engine speed increases, spinning weights advance the timing. There is also a vacuum advance unit which advances timing during part throttle conditions. When there is less air-fuel mixture in the cylinder, it burns more slowly, so we need to ignite it sooner. The vacuum advance uses intake manifold vacuum to move the breaker plate inside the distributor, which adjusts the timing. Together, these mechanisms make sure the spark always happens at the right moment, no matter the engine load or speed. So that's a detailed look at the classic Bosch contact point ignition system, the one used in the Volvo 140 series and Amazon. Even though it's been replaced by modern electronics, it's still a brilliant piece of engineering. And if you maintain it well, it can deliver great performance even today. If you found this helpful or have questions about your own classic Volvo, drop a comment below.